Hey everyone, Radhe Radhe. My name is Alan Pasha, and today we will be continuing our infrastructure as code playlist, a course where we were discussing about some of the most prominent and the most important and dominating tools, as well as also some of the most best practices in the whole domain of infrastructure as code. What do we mean by infrastructure? What do we mean by IAC? Why was this particular idea was actually being adopted by most of the engineers and the applications as well. All big companies like Google and many other cloud providers. And what are the benefits of this? We have already discussed about all those things. If you are new to this channel, then you can yeah jump on to my previous playlist and watch what do we mean by infrastructure at first, and then get introduced with the IAC and its benefits as well. So today we'll be discussing about one of the most famous and the dominating tool in the whole IAC, that is Terraform. Some way or other, any particular person or a developer who's an infrastructure expert, he must have used Terraform in some way at some point in his life, of his professional life. So it's the first day where we'll be discussing about some of the introductory kind of the points of Terraform, and then later on we'll jump on to making some of the real life projects as well. Like starting up with the local project, like your particular local system, and then deploying it onto the cloud, and then later we'll be using some of the cloud services as well, and integrating some of the tools as well on the whole application layer. So yeah, uh, we'll be discussing about that. So what do we mean by Terraform? Terraform is a kind of tool that is helpful in converting the whole idea of infrastructure on the and bringing it in the form of the manifests, YAML manifest files, and and the configuration files, and then pushing it onto your repository, and then later you can use it, view it in the human readable form, instead of going on to any particular to all the resources that we want to adopt in our infrastructure, and then copying its APIs and then doing all those tedious work. Instead of that, you can just define your infrastructure with the help of YAML manifest files, configuration files, and then with the help of various components of the Terraform that are actually being adopted in its infrastructure. You can build up your application in your way. So yeah. So it's a particular kind of a tool that uses HCL. HCL stands for HashiCorp Configuration Language. It's language specific, so you will have to use that HCL only for building up the whole infrastructure of your application. And then it Terraform actually works on a declarative approach, in which we usually have current state and the declare the final state that we want at the end of the whole development cycle. So we'll be in the later videos we'll be defining the desired state as well, and then yeah, we'll be using some of the resources and many other components as well. So it's a declarative approach. It works on the declarative approach. It automates the whole infrastructure life cycle management as well, and it uses the version control thing as well. Like on the GitHubs, you can see the repositories or any particular change that has been applied to your repository, that is actually being pushed on the version control layer as well. Like you can see what has been changed in the past, and anybody then you can also come back to the earlier stage if that was much more favorable at earlier stage. So yeah, and it's reusable as well. Later on we'll be discussing about the Terraform modules as well. It's a reusable block of codes, reusable kind of a package. Yeah, we will come on to that particular topic as well in the future. Not today. Today we'll be focusing on the introductory part. So yeah, these are some of the most more some of the uh, major points of the Terraform. What do we mean by Terraform? What are some of the major points like of Terraform? How does it work? It works under the declarative approach. It uses the version control as well. It's a reusable approach of tool as well. And then later, what is the backend of Terraform? Backend layer, backend function. So Terraform usually uses the clouds clouds with the help of the API. It communicates with the cloud providers with the help of an API, and that API that is actually being handled with the help of the providers. It's a kind of a Terraform layer that is known as provider. That provider usually uses the configuration files and then pushes it in the form of the YAML files, like different providers, different cloud providers like the Amazon AWS or the Microsoft Azure or the Alibaba cloud provider or GCP or Kubernetes or even the local file local provider as well has been provided by the platform, so that you can try it on your local system at first before pushing it onto your cloud provider and increasing the billing of your resources. So yeah, we'll be discussing about that as well. We'll be building up a huge whole project by integrating different functionalities and services as well, like the database as well, and then the version controls and GitLab and various other things as well. So yeah, it's a provider. So let's see.
Yeah, yeah. So it's the HashiCorp registry. HashiCorp is actually the organization that is actually managing the Terraform. Terraform has been managed by HashiCorp. HashiCorp has a lot of different tools as well. The HashiCorp Vault as well. Later in the project, we'll also use HashiCorp Vault to hide our secrets and our manifest and our whole workloads. So it is Terraform registry. We can look for different providers over here to like the Amazon and Azure, GCP, Kubernetes, Alibaba Cloud, Oracle Cloud Infrastructure. All those particular cloud providers have their own providers, like the provider layer for Terraform to be used. If we use AWS, for instance, then we can see it has a different syntax for the cloud providers. Yeah, it has different syntax for the providers layer of Terraform. Different cloud providers have different syntax. You can just instead of researching a lot on those providers, what should be right in our configuration files, you can just jump onto the HashiCorp registry and then just look for some of these examples as well, like the Terraform that is defining the whole file, the whole syntax, Terraform, then required providers. Here we'll answer some of the providers, and we can list some of the providers like the AWS or the Azure, and we can even store multiple providers, whichever we want. Like over here, it is AWS. Source is this much, and it's the address, the API, or the cloud provider, then the version that is actually being announced, which version of the provider it is using, our Terraform, and then later we can also explain or point out some like which are some of the different locations where we want our application to be hosted, like whether it is US East or the Asia or Europe or different cloud providers or the locations as well. And then later we can define those particular about those particular locations as well. Like it's we yeah, discussing all about the VPCs, setting up the VPC as the bucket, AKS, security groups as well. All those things are actually being yeah, listed over here. Even if you are a newbie who doesn't have any, who doesn't wants to, explore this particular platform by exposing your AWS or the Microsoft keys or using up a lot of resources for trying out a new tool. Nobody wants that at the initial level. So we can, instead of that, we can just use a HashiCorp local files. Yeah, HashiCorp local files is a kind of a local provider, yeah, local provider where we can use HashiCorp um, and then explain and then explore more about this whole particular tool. Like the required provider is local, and then the source is HashiCorp slash local version, and then we can define our location as well, whether it is location or what do we mean, what do we want in our infrastructure at the initial level. So it is about discussing the providers, the Terraform provider layer. And then later we have a resource layer as well, and the modules as well, and various other things. So we'll be discussing about them all also. We actually we hold kind of a three steps of the whole managing or the development of the Terraform or our infrastructure as code layer.
And those steps are majorly defined or being broken up in three parts. That is the initial level, when we apply all those different the different features, the parts that we have learned at the moment. And then that is actually being known as the write layer, where we write or define our .tf file, Terraform file. And then later we usually push or ask for at first, are all these changes or those resources that has been actually defined in our file, are all those working correctly, or are we really need to push all those changes at first. So that is the plan layer, like the Terraform plan. And then later, after we have uh, accepted that we want to change our whole infrastructure and the way we have defined our configuration files, then we can use the Terraform apply command as well. So it will give a lot of the message, like what are the particular files that has been changed and that were actually deleted. It's a kind of a monolithic application, and not monolithic. It works on kind of a feature in which the earlier file that were having some other features that are actually being changed, instead of using the same file, it uses another file that has been replicated in the same way and then changed whichever things we want to change. And then that has been pushed onto our repository, and then the version controls usually list that particular thing. And then if we really want, then we can just come back to the earlier stage or the previous stage, and then look uh, what are some of the changes or what are the results of it, like for the A/B testing or the kernel deployment or various other things. So yeah, uh, so these are some of the major three steps of our Terraform. And then we have then the initial command that's used in our repository after defining all the providers is usually the Terraform init. Terraform init usually brings up and builds all the particular files that are actually being needed in our repository, like the Terraform modules or the Terraform log.tf. It actually brings on the whole information about the providers that we have used at the moment, and then and also about the versions that we are using, and that is actually available at the HashiCorp uh, repository. So yeah, in the next video we'll be discussing about the resources, modules, state files, desired files, various other concepts as well, and maybe most probably we'll be building up a real time project as well alongside with our whole explanation, because that's needed. This whole explanation isn't that useful if we aren't really applying all those concepts in the real life projects. So, yeah. Thanks a lot. Yeah, hold on to your seats for the next video that will be uploaded soon, maybe in this week. Yeah, you can also view a playlist that I have launched alongside, that is on focused upon the platform engineering. If you doesn't know anything about the platform engineering, it is a kind of a branch of engineering that is actually believed to replace the DevOps. So is it really going to replace the DevOps thing? So the answer is kind of yes, but not the DevOps engineers, because the DevOps engineer and the software engineers that are included in the team are the same guys who are included in the platform engineering team as well. And yes, it does holds a lot of capabilities and efficiency as well. So I just started the platform engineering playlist as well, and then the alongside I'll be uploading a lot of videos about the platform engineering as well, and IAC as well, and an earlier playlist as well that I launched earlier, that is service mesh. I'll be uploading a lot of videos about the service mesh, ambient mesh, and various other concepts as well, like the Kuma, Kong, and API gateways and various other alternatives that are available in the whole market, like the Cilium, EVPF. Those aren't using service mesh capabilities. It holds a lot of cons as well. It holds a lot of advantages like the pros, but it has a lot of cons as well. And that's why Istio, who majorly manages the whole service mesh, they have launched an ambient mesh mode. That's really interesting. So we'll be discussing about ambient mesh as well. If you are an cloud architect, then you'll love seeing all these videos that will be coming in the near future in all three of these particular playlists. And I'll be launching new playlists as well about the sustainability part and the OpenSSF and various other projects as well. So yeah, see you in the KubeCon EU as well, KubeCon EU 2025, and that will be held between 1 to 4th of April. Most probably might get selected. I've also applied for the sponsorship, so let's see what happens.